Sir, we are starting the webinar, sir.
Okay.
Namaskar. I am Dr. Ritesh Das, Associate Professor and Head, Department of Electrical Engineering, Christian College of Engineering Technology, Bhilai, and with me, my co-host, Mr. Sridhar Burla, sir, and Munna Biswal, sir. A very good morning to one and all present on this webinar. Respected Reverend Father George C. Varughese, the Executive Vice Chairman, CCET Bhilai, Principal Madam Dr. Mrs. Dipali Soren, HODs of various departments, professors, research scholars, and my dear friends, a warm welcome to this webinar on effect of load on frequency of power system and its control. It is an honor and privilege to welcome Dr. Manoj Kumar Maharana sir, Associate Professor, School of Electrical Engineering, KIT University and Institute of Eminence, Bhubaneswar. As an eminent scholar, Dr. Maharana has received his PhD from IIT Madras. He has a vast experience in the field of power system control and contingency analysis. He has published many research papers, mostly indexed in IEEE, Web of Science, and Scopus. Sir has also guided a number of PhD scholars. He has also extended some chapters in one of the most beautiful book of electrical engineering, that is Modern Power System Analysis by D.P. Kothari sir. Once again, from the entire CCT family, I welcome you, sir.
Thank you.
So just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the chat box in your YouTube control panel. I'll bring them up during the presentation and we'll also have some time for question at the end. Keep your mic and video on mute mode for better clarity in the program. We are also streaming this program on YouTube at Electrical Engineering CCT Bhilai. So if you have any difficulties, then you can also listen this webinar at YouTube. Now I am handing over the session to our guest for enlighten us on the effect of load on the frequency of power system and its control. Sir, you're online.
Okay. Thank you. So thank you for the welcoming for me. So I'm Dr. M.K. Maharana. So I'm going to start today my presentation.
Sir.
Effect of load on the frequency of power system and its control. So Ritesh, can you put the slide, please? Ritesh.
Sir, I'm listening, sir.
Can you put? Yeah, it's okay. It's coming.
Yeah, sir.
Okay. So go to the next slide. Okay. So today, as the topic is related to the effect of frequency on the load. So today first we are going to discuss what is electrical load. Then we can go for electrical power and how the energy conversion is taken places from one source to another. Then the load curve, what is its requirement. The region for maintaining constant frequency. Then we can go for to maintain the frequency. We have to record a speed governing system, certain things related to speed governing system, then load frequency control and different control technique. So this we are going to discuss. Okay, let's see. So as we say load, first we have to know what is mean by load. Everywhere we are saying the load. Basically, when load came, we thought that it's a mechanical type of things, but electrical also loads are there. So on the load, an electrical load is the part of an electrical circuit in which current is transformed into something useful. That meaning is, we know that our system is a constant voltage system. So to do any useful work, when you switch on any light also, then the light start drawing certain amount of current. So when it start drawing certain amount of current, it is going to give us the light. So that's why the load in electrical is no doubt it is the component which is consume the electric current. So you have to know the load means it's a electrical current. An electrical load is an electrical component or proportion to the circuit that consume electric power. As voltage is there in the system, because without potential difference, we know there is no current will flow. So as there is a potential difference and some current is going to flow depending upon the circuit. So current into voltage is going to give the power. So okay, so power have a lot of things are there. So for that, because the load basically what we understand in the layman for which is going to be consumed some active electric power. That is called our load. Then when you apply the load, what happen? It is start opposing the sources. The which sources the powers are there, it is start opposing the sources. So then what is the main example of the load? So whatever the component which is going to be convert in the form of a heating, light, motion. So there is a certain examples are shown here. You can see if you switch on, the bulb will going to glow. So this is also going to consume certain amount of current or load. And the motor going to be run, it is also going to consume some current. Or when in your household you are using lot of heating, not only household, in industry also they are using heating. So these are basically called the different type of load. So what you understand from here, the component which consume the active power, and this active power consumption will come through the flow of current, or indirectly it is consume the low current. So that's why you can call the load. Okay, now next slide please. Now when you go for the load, so we are going to get the power, because we said the when the load is here, it is going to be consuming power. Now when the power, electrical power, is the rate per unit time at which electrical energy is transferred by electrical circuit, or the rate of flow of energy first given point of the circuit. That means what happened? The electric power is the rate of per unit electrical energy which is going to be transferred or flow from one source to the load, or who is going to be consume the power, it have to transfer with respect to time from one point to the another point. Which is going to give that power, it is called the source. Who is consuming, that is called the sink or the load. Okay, now when the power is coming, so power have a basically, as we know, depending upon our electrical generation or system, so there is a two type of power, either AC power or DC power. So when we can say the DC power, it is a purely DC, there is a no frequency involved, or there is a no change. So basically the DC power is no doubt, it is the product of the voltage and current. As in the DC, the voltage and current in the same person, same amount of quantity, or not same, but it is in the same phase, we can say. So that's why the product is called the power, which is called the DC power. For an example, either a battery, fuel cell, or the solar panel, whatever things are giving, they are going to give you the DC power. Okay, but DC power, there is a certain problem, a certain drawback. What is the drawback? Because initially days we cannot generate huge amount of DC power component, because if you remember, because there is a no chance except the battery where, or the energy storage devices, we cannot produce the DC power. But when our power consumption is more, so we have to be AC. Why? Because any flux is going to cut depending upon the Faraday law of electromagnetic induction. We are going to get the rate of change of flux. When there is a rate of change of flux is got to cut by the coil, then the EMF is going to induce. So as there is a rate of change of flux, it is a time varying quantity, so there is no chance we are going to get the DC. That's why the power is AC. So as the initially the DC is not much popular, so that's why the AC is coming in the picture. Because nowadays we can see by the development of the research, HVDC, so nowadays DC also a huge amount of things is coming, huge amount of DC power. Okay, so now let's come for the AC power. So AC power have a three component. One is called the active power, then reactive power, and apparent power.